Den rekommendationen är att undvika att installera GitHub. Alltså PC-för. Sen måste man ha paket som har nödvändiga skulle fungera.
Men det finns en annan som heter Gitcore.
Nej, man kan ju ta dem var för sig. Men alltså, jag var väl slarvig och tittade, men normalt om det står emot med stora bokstäver så brukar jag reagera. Så att jag tyckte inte det såg ut som så.
Jag har aldrig varit med om att han tagit bort något.
Men att det tog bort syften.
Det är jättekonstigt.
Och inte slutet.
Det är också så. Varför skulle jag inte ha någonting att göra med IP-table?
Ja, men det kan vara så att Git-all innehåller något paket. Det är Buster, det är testing här. Så gissningen är att Git-all pekar på något paket som inte uppgraderats så att det är kompatibelt med Buster. Och då beror det av en massa äldre versioner som det är att nya versioner försvinner. Något i den där stilen.
Och då
blir det väldigt dåligt.
Men det problemet hade vi ju med en annan dator. Det var en av studenterna i doktorandkursen som inte ville ha kvar Python 2.7. Så då råkade de göra remove, fast auto-remove på Python 2.7. Så då tog de ju bort alla dependencies. Så då slutade ju GNOME fungera. För det använder ju Python 2.7 hela tiden.
Det är just som att det är väldigt svårt att ta bort något. Det bästa sättet är att inte installera GNOME från början.
Jag har ju Ubuntu 16 LTS på den här. Bara för att jag vill ha någonting som är LTS. Som jag är van vid. Jag vet exakt vad det är på den.
Så brukar jag ha ett tag att jag har någon stabil version. Men det är så att om man har en alldeles ny laptop så måste man ha Bleeding Edge för att så att det ska funka som man vill.
Jo. Som sagt, Arch Linux hade varit bra. Om man har tid.
Jag är så väldigt inkörd på det. Jag började med Slackware. Det var på den tiden om man installerade Linux. Och man sa på sig att det här är ett gäster. Det var ett enormt steg framåt om man kunde externera det stället för att kunde man ta resten av nästa. Men den första Linux-installationen det var 40-50-talet och var 44 megabytes disketter.
Jag har nog aldrig installerat ett operativsystem på disketter. Jag kommer ihåg att jag sparade. Jag kommer ihåg att jag sparade DOS-filer på en sån här 3,5.
Där hade man allting på hela sitt liv.
Det var så länge sedan.
360K. Hade man tur var det 1,2 megabytes diskett.
Ja. Lite annorlunda då.
Det är lite annorlunda.
Band från finska Lappland. Jag är som musikprodukt som kommer bort 64.
Okay, that's going into my playlist later.
Vad är det ett bidrag till kursen? How to irritate your colleagues?
That's a problem.
Okay, are we all wrong? Yeah, I'm missing a few. Actually, just 1 minute past. Should we wait for another second? 3 minutes past. Okay, then let's start. Okay, we left off at list comprehension. Yes. So let's start a new file. And here we have a one-liner. And what this is called, it's called list comprehension. And it's a really nice and fast way to initialize a list, so to create a new list. And I'll go through the syntax first. So first, we start with square brackets, as usual when we start a list. But this time, what we do is that we write a for statement within the list. And how you should think about this syntax is like this. Don't look at that part. And then here, just write a regular old for loop. So for a variable that you're going to iterate as in and something that you can iterate over. And then what actually goes into the list, that's a function of the I, goes there. That's this one. So if you just write this example and do print L,
1, 2, 3, 4, 5.
Just do print L here, and look at what it gets you.
What you say, you print out inside the bracket?
No, just print L below. I didn't put it in this example because but I want you to see the output before we move on. So this creates a list with elements 0, 1, 2, 3, 4, 5, 6, 8, and 9.
7.
Yes, and 7. Oh, I forgot. That's why I need more coffee. I see a few of you actually got coffee. Yeah. So before we did a for loop that did exactly this, and then that for loop iterated 1 through 9. And now this syntax you will think of as defining a for loop here, and that's just before the for loop, you write what's going into the list. So here you just put the index into the list. But you could do whatever here. That's a function of I. You could have a function call where I is the input, or you could do I squared, and then you would get all the squares.
It means that what comes after defines I.
Yes.
And if you would type f of I, a function call, whatever, if it still works.
Yeah. So we can actually add to this even more. So you can do one more addition to this list comparison, which is you can put an if statement right after the for loop. So here we still have this print out. We still have this thing, but then basically what this part says, this if statement, is the if statement of a function of the iterable, and then it says skip the iteration if this if statement is false. So here, this percent sign is the modulus operator. So this takes the mod 2 of I. So this basically, this boolean checks if it's odd or even. If it's even, this is true. If it's odd, it's false. So that means that it will skip every loop where I is odd and just save the even number.
Two means that one again.
Yes. And this percent sign has had a few uses today, but in the context of numbers, this is the modulus operator.
This is 0, it's the behind.
Yes, it's the. So if you do mod, so if 9 mod 3 is 0, 10 mod 3 is 1, and so on.
Is this syntax only valid inside list brackets?
Yes.
It doesn't work otherwise.
No. So this is list comprehension.
So this percent is mod.
Yes.
Yeah, it's absolutely similar to array constructor in Fortran.
No, yeah.
It's absolutely safe.
Yeah, but pass, yeah, I just need to pass.
Okay.
Pass is the kind of students.
You can use more. So,
But in principle, after a variable inside brackets, it can be any kind of statement that is operating on that variable.
yes,
And then the result will be what that statement resulted in.
yes, in the list,
Yeah.
as you iterate. So here, let's say I had a function that returned the nth Fibonacci number. Then I could just write the Fibonacci sequence of E here, and I would actually get all the Fibonacci numbers between 0 and 10. So it's a very quick and nice way to initialize lists and to create lists. And one of the first questions I usually get when I show this is, that has to be slow. So I did some testing. So here I did a list comprehension where I did for I in range 1,000. So I generated 1,000 numbers, and then I saved the square of them. So times is to the power of in Python. So star is multiplication, and star is power. So this saves all squares between 1 and 999. And this executed on average in 0.6 seconds. And if I do this, I create an empty list, and I do a for loop, and then I append the square. It takes 0.87 seconds.
It's obvious.
Yeah. So it's 15% slower. And if I do this, this is a bit of, we haven't gone through how this syntax actually works yet. But basically what this is a pre-allocation. And if I do pre-allocation and then assignment, it's a bit faster, but still not as fast as this. And I mean, so list comprehension is so built into Python that Python is able to optimize it behind the scenes, and it's actually very fast. But I was talking about how you should actually use NumPy. So let's compare the winner with NumPy. So this is creating the list with list comprehension in Python, 0.6 seconds. And this is the equivalent in NumPy, 0.02 seconds. So doing the same thing in NumPy was like 1,500% faster. And that's just because NumPy goes to C when it does this.
Okay. I'll see.
List comprehension is a bit more flexible because it's working inside the Python narrative. But for just doing stuff like this, just initializing a list of squares or doing anything with numbers and initialization, just this is always faster, always. So, yeah. Any questions?
If you put the N, NRN.
So NumPy is NumPy an object that has methods like arange? And I think the syntax n.arange. It seems like an object with a method.
Yeah, it's not the same. So we will talk about how libraries work soon. But for now, let's talk about list comprehension and functions, and then we'll talk about libraries after. Because it's the same syntax, but it's not the same.
Okay.
Okay. So here we have this example where we just picked out even numbers, and now we're going to do this magic line again, because I want to show you how to use list comprehension practically when you have some data. So let's generate this A with this line, this means generate 100 random numbers. And then we do this list comparison, just to sort of show you what can be done with it. So here, we take x plus 5. And what is x? Well, x is a random number in A, and A is 100 random numbers. But we only save the ones that are inside 0.5. And you can go back. So I want you to write this, and we'll talk more about NumPy later. But I want you to write this to show you how list comprehension can be used also together with NumPy.
What this x go on again?
So that's just it's the same as I here. It's just a variable that
Variable, okay, yeah. Okay.
For the iteration assignment.
Yeah,
Does it care about you have spaces around equal signs and square brackets, and is it just for?
It's just for
readability.
I probably shouldn't put spaces here, but I did it for some reason when I wrote this example. Someone who knows PEP8 is probably shaking his head. Yes, yeah. So actually, in 3 weeks, I will have a lecture about style guides and PEP8 and a specific version of style guides for scientists that I like. So those who are interested can come to that lecture.
At this point, it's probably worthwhile to mention what the style guide actually is.
Oh, it's like etiquette for programming. So yeah, when you write so it's things like when you write an equation, have spaces between plus and minus signs, and not between multiplication and division signs.
It's a hint for readability, because the multiplication is finding stronger than the addition. So it's just for readability. That's all there is.
The logical operator.
No, at most one space, but yes.
And then some variable. There are things like variable conventions that are actually used internally as a system in Python in classes, for example. If you put 1 underscore, it's sort of, you shouldn't really access it, but you can. If it's 2 underscore, it's completely private. You can't do anything with it outside. If it's no underscore, it's fine. You should be able to access things like that. It's not the point of this example. Okay, and then the last line. This last line is exactly the same, but to show you that you can use what's here as inputs to a function. So in this case, we do loop x over the elements in A, and then we multiply them by 5 and turn them into integers. So has everyone completed the examples?
Not yet. Afterward.
Do you ever have?
You say
Yes.
what is x again?
X is the variable that is assigned to the item that we're iterating over. How do you say, what's the name for the thing that you're taking out of an iterable? I don't remember the English name for it. Är det inte... Jag skulle säga iterationsobjektet.
Isn't it like an I in the form?
Yeah. So
in here?
I'll draw.
Loop index very simple. Cycle index something similar.
It's just an element of the.
So like this. First loop, so this list is an iterable. First loop, so this list is an iterable. And we say that the name for the variable that comes out of the iterable should be A. So we have A here. So what does the loop do? Well, it takes the first element and say A is equal to 5. And then it takes the next loop, it says A is equal to 6. And then the next loop, it takes A is equal to 7. So it's just the name that is going to use on this side of the equal sign. So X, in this case, is A. And in the top example, it's I. It's just the name that it's going to get.
And in that way, you can also put like names in it, like all the names of the members of this group, and then you go through this index with all the names.
Yeah, that could work.
Okay, so that can't be done.
But any questions about list comprehension?
What does line 8 then say?
So line 8 says take all elements of A that are between minus 0.5 and plus 0.5 and add 5 to them and save them in this list in spoken language.
So n dot up is what did you say?
It's just absolute value.
Oh,
I just did it so that I didn't have to write the AND statement here.
So it's between 0 and 0.5.
Minus 0.5 and 0.5.
And the last one takes every value in A and makes an integer of the value multiplied by 5.
Yes.
Yeah.
So this returns a list of integers. And there it doesn't do rounding. There it actually just removes all the decimals. So if you get 4.9, it would be 4.
Yeah, that's right. That's 2.5 is 2.
Yeah.
Do you have things like round or
Yes.
tile and floor?
Yeah. Round, floor, seal, all of these regular ones. Okay, so now we're going to true list comprehension. This was we needed to get this out of the way too to be able to talk about more stuff later. So now, if there are more questions? Yes.
Yes, there's no way to use else expressions in this comprehension.
What do you say?
I wonder if there's a way to use else expressions for optional values, like in some other languages.
Oh.
As far as I understand, there's not.
Let's see if you can get around this somehow.
Yes, you can.
Yes.
You can, instead of the, so for example, if you have in line 3, you have 4, so I in range, but instead of the I at the very front, you can actually write an inline if then else condition.
Yes.
So you can write something like 5 if I is less than 5, or else 3 or something close to this. So you can put an inline if then else condition.
Or you could just call a function that does that.
Yeah, but you can also do it inline.
Yeah.
I mean,
yes, you can do inline, but Pep. Don't do too long inlines.
No, I agree, but the question was about inlining, right?
Yeah. So.
What is
Yeah.
Is it it's not the instrument that starts it?
No.
No. It's just the Python whatever what's it called, the Python something
Enhancement something.
Yeah, it's style guide on how to write, and it's also what the publications when they do update it for. Like PAPE 836 came with the F style formatting or whatever. Yeah. Okay, let's move on. Now we're going to write functions. So I've used this keyword before, but I didn't say what it was. So now, def. Def is the keyword in Python to create a function. So the syntax is you write def, you have a space, double bless you, and then you have the function name, and then you have parentheses and the input parameters to that function. And then you end with a colon to indicate that you're beginning a new block. And then what you're going to give out of the function is given by a return. And then parentheses. What?
Why parentheses?
I just like to do that to show, yeah.
Okay.
A plus B.
Then, question. Function fun
Yes.
includes print or not?
Not.
Okay.
How you can understand that fun include only return? So, for example, here's return a plus b, but you can write function quite.
Yeah, you can have huge functions.
How you understand from this syntaxes that function is end?
Because the indentation ends.
But return is the last operator in function.
Yes, return when it returns, the function is done.
But sometimes you can make function without return.
Yes, and then
In this
it will
case-
return none when it's done.
No,
Right.
the function ends when the indentation block ends.
Yes.
So when the next line is no longer the same level of indentation, but before, so shorter, then it says, okay, the function ends here.
And it's the same with if statements too. I mean, otherwise you would have to have an end operator for if statements too. But it's the universal end operator is the end of indentation.
Okay. Maybe.
Anyway, so also print is really smart because print knows to convert everything it gets to some printable format. Usually, it tries to convert it to strings. So whenever you print something, it will usually work printing it. So before you actually run this, can I get some suggestions of what you think that these lines will return?
I guess that line 5 will be concatenation of strings.
That's a pretty good guess.
And the next one would be 1 plus 10, 2 plus 11, and so on. So yes.
That's a pretty reasonable guess. How about the last one? Any ideas?
Maybe it will convert 5.6 to a string in concatenate.
Okay, so for this, yeah, error. Okay, so we have so line 7 with error. Any more? So do we have a result for 5? What did 5 do? Yeah, concatenation.
I have an error on return A plus B. A plus B.
Yeah, for this one. Or
What do you know which one?
so just remove this line.
Ah, yes, line 2.
Do you need a return?
It was error.
So this returned 9, this returned the concatenation, and what did 6 return? Did it do element-wise addition or?
No, it added the list.
Yes, it also does concatenation. So what we are seeing here is something super powerful about Python. Since we don't have any declared types, this function can take whatever, and it doesn't care. It just takes 2 objects. And then it looks, is plus defined for these 2 objects. And it wasn't for strings and floats, but plus is defined for integers and strings and lists. But for integers, it just does addition. For strings, it concatenates them together to one list. That makes sense. And for lists, it also does the same thing. it actually takes the list and pastes them together.
And the last one should be an error.
Yes, the last one should be an error.
So they have to be of same type.
Not necessarily. You could write a function, or you could write a class which has plus defined for two completely different types. And we didn't have time to do this today. But originally, this lecture had an example actually where you wrote a class and you defined the plus function for that class, and you were able to add integers to your own object. So I mean, it could be. You basically just have to look up what is defined for that class and how it works. For these basic data types, you can just, now you know how these work. Plus is concatenation, and for both strings and lists. And you can look up the other stuff, how it works, on the Python documentation. Do we have any questions so far about functions?
Yes.
Yeah.
I just tried the same with minus. Why does that doesn't work? Why does
Does it make sense to take one string minus another? I mean, what would that return?
But for the first one, it's 4 plus 5, right?
Yes.
So here, if it's minus, it will be 4 minus 5
Yeah.
minus 1.
That works.
For me, doesn't. I mean, in this one, it doesn't.
Aha, plus, that's why, okay. So, I see.
Doesn't it work?
In the line 6, to add
It works.
like 1 plus 10, 2 plus 11.
Again, I would say use NumPy. Because no, but seriously, like plus for NumPy is actually defined element-wise. So if you, A and B are NumPy arrays,
Here it's just object one.
yeah, here it would do. If these were NumPy arrays, it would do this plus this plus this.
Then here's full list, but if you replace by vector, with vector, what is different with vector?
I didn't hear.
Here you have a list.
Yes.
But if you put here vector,
You mean tuple?
vector, so
Array.
yeah, one-dimensional array, yeah. And then it's a tuple. Okay, I will check.
Yeah.
The
Concatenate into a new tuple.
Vector or it will be similar. Yeah, okay, I will check.
line 6, I get 1, 2, 3, 10, 11, 12.
Yes. So it concatenates.
Okay.
Yeah.
Before you mentioned, so I tried to see the function after the print statement. Spider will give some warning.
Yes.
Fine, but it still works.
Yeah.
It doesn't only read line by line, but it's like you find the function in the end.
But that's probably not because of how Python works. That's probably because of the precompiled PyC file. But that's another thing. Yeah.
For vector, it's also concatenation. Okay. For vector, it's also concatenation.
Yeah.
Same with that.
Very good. So how can we make the instead of lines? I want to get the result of the 11, 13, and 15. How can we
Use NumPy. That's the simple question answer. That's why we will. No, that's why we will use. Yeah. Okay. Let's move on. We have some additional keywords to go through before we move on.
No.
Okay. So these were the most important keywords. Now we're going through the most important data types, and we're going through most important keywords. I want to mention some others, just because this is a basic Python course, so I should really mention everything. So we have lambda functions. This is the regular way to define a function. And this is if you do it with a lambda statement. So here, you start with the function name, is equals to, and then you write the keyword lambda. And then after the keyword lambda and a space, you list the input parameters. Then you do colon, and you write the Python statement that will be returned. So this is basically what's inside these parentheses. It evaluates this statement and returns it. So it's a one-line way of writing functions.
It's about the same number of words as above.
Yes. There's a reason for it existing.
Is it faster?
No.
That way?
No. But this is called lambda functions.
You could basically use this as one line in the code to define this function, and
yes.
then use it then always referring to sandwich.
Yeah. And if you would do this with strings, for example, you would get concatenation as usual. You could call sandwich of a string, and you would get, as we did with the last example. Okay, so let's, actually, I don't know if we have time to go through this. We should do it anyway. Okay. Let's do an example with map. So, yeah, well, they're scientists. I have to go through this. Save this as a new file. First, create a list. Define a function that does something, the square, for example. And then we will do this thing, map. And how map works is that as the first argument, it takes the handle of a function, so the name of a function. And as the second argument, it takes an iterable, something you can iterate over. And then it applies this function to every item in the iterable. And if you're using Python 3 point whatever it was, 4 or 5, or I don't remember when they changed it, but if you do this in one of the latest version of Python, you will not get a list here, you will actually get a map object. Yes, I know they changed it. So if you do print b, can someone tell me what you get, because I don't remember the exact wording.
Map object at address.
Yeah. So you get a map object. And that's because now you've only set up the computation. And I won't go into the specifics of what this map object is, but if you write list parentheses b, then it actually executes the calculation for everything and returns it as a list. So if you just do this and run the program, you should get a list. Yes. So do a list of b. And then we'll talk about the implementation of lambda functions in this example.
What is a map?
It's a map, like mapping function in mathematics. You have a map. Only we're not mapping Riemann spaces, we're mapping lists.
I am fine. I want to hold on. Map object. No. It says map object, yes. But why we did map object?
Yeah, that's because it hasn't done the calculation yet. So if you do list here, list parentheses b, it will actually do the calculation and convert it to list. So actually, I should have put an extra slide here where I have just that change. But so has everyone tried to put list parentheses B here instead of just B? And you get the list? Yeah. So that's how map works. Now we can rewrite this example with lambda functions. So let's ignore lines 8 to 12 and just look at this one. So here, instead of putting this SQ function as the first argument, we actually wrote a lambda function in the first argument instead. So this is, I think at least, is a very good way to use lambda functions. When you are calling a bunch of maps and you're remapping data to the left and right, and this also ensures that this function just exists here. So if you write lambda x, you say that this is a function with that one input parameter, and then you define what's supposed to happen with that input parameter. And it does the exact same thing as the code previously.
I didn't understand it.
Do we have some questions about just these two lines?
Yeah, to run. Have you ever done a speed comparison between map and the list creation mode?
Yes, and map is faster, if I remember.
Would make sense.
Yes, yeah. Because I remember just memorizing to use map instead of that, and there has to be a reason for it. And I think I did it like a year ago. I don't remember. Actually, map is also really good because when you apply this to some multi-computing libraries, it's actually just map. You're never going to use this comprehension in supercomputing or parallelization.
Yeah, but I'm asking because it kind of makes sense now that we learned what this comprehension is, that we could use the exact same thing using this comprehension instead of map.
Yes.
But since, this comprehension is fast, and map is faster.
Yeah. And also map extends to some other areas and points. That's, well, it's good to know both. And also these are functions that are super useful when you do data analysis. So, and what I want you to keep doing after this example is filter and reduce. And I can just tell you that in supercomputing, in principle, any operation can be boiled down into combinations of map and reduce. Any mathematical calculation can be written in terms of map and reduce. So if you just learn how to do map and reduce on a supercomputing system, you can implement whatever you want. Basically.
So for the lambda means
lambda means define a function.
Yes.
define the function.
Yeah.
Reduce.
Lambda
Yes.
means define.
Reduce is not defined.
Yes, that's so let's talk about the rest of the examples before. It's this line. Yes. So this line uses the filter function, and filter is also a part of standard Python. And filter does exactly what you think it does. It filters the data. So here you also give it a function as the first argument, but this function should always return true or false. And it keeps all the elements which the function returns true for, and it throws out all the other elements. So here we are just saying this is the Boolean that it should return, and run this filter on A. Was that understandable? Okay.
So
as I understand line 5,
Yes.
it will square x, and x is all A.
Yeah, all the elements in A.
But what does map in itself do?
It does the actual iteration over all elements in A and does the squaring and then does the saving in a new data structure. Otherwise, you would have to do a for loop and initialize a new list and append that list with the new entries and everything. But map actually does that for you in like one function.
I need to print A to understand what I'm doing. That's exactly what
And then the last one, this reduce, it's also a staple in computer big data computations. So what the reduce does is that it takes an iterable and then it runs a binary function over that iterable. So it works like this. I'll show you on this thing if everyone can see this. I don't know. I'll try. So
Switch on light function.
or should okay. So maybe I should do that first. So what it does is you have 1, 2, and 3, and I'll do 4 here. And then reduce takes the binary function in. So what I mean is it takes a function with 2 input arguments. So it takes the first 2 arguments, 1 and 2, puts them into the function. So function of 1 and 2. And in this case, it's plus. So the return of this would be 3. And then you can think of it as a new list with items 3, 3, and 4, because it reduced this one into 3. And then it does it again. So it takes 3 and 3, function of 3 and 3. That's equal to 6. And then you get a new list which have 6 and 4. And then it keeps doing this reduction of the list until it's out of list, until there's just one element left. And since plus in this case is an associative operator, this basically just does sum of the list. It just sums the list because it takes plus between every element. So this should reduce the list to what is the sum of all the integers between 0 and 9. It's like 45 something. 1 plus 2 plus 3 plus 4 plus 5. Plus
This is interesting. When I print list D, it's 0.
yes. That's because D is just one number.
Okay. And, okay, yeah, now I understand.
Okay, so now we have too much light to see this thing.
I do not really understand why they become
Did this thing make sense?
Yeah.
Reduce. This is the same thing as doing this a sum on all the elements in A, summing all the elements in A.
Is it restricted to 2 elements, or could you write X, Y, Z?
something wrong.
It wouldn't work with X, Y, Z because it has to do it like takes 2 elements, reduces the list, takes 2 elements, reduces the list.
That is due to the way reduce works.
Yes. You could write your own function that does it with 3 elements, but then you have to figure out a clever way of how does that actually work with operators. One of the real nice things about reduce is that, as I said, if the function that you're writing here is associative, it's the same as just putting that function between all the elements. So plus is associative, so that's doing this is the same as putting plus between all the elements in A and just summing the list. And there are lots of operands that are associative, like matrix multiplication is associative. So if you do matrix multiplication here and you want to multiply 10 matrices, and you have a list of 10 matrices, you actually get the matrix multiplication of 10 matrices. Yes, you can use NumPy because you can have NumPy matrices as elements in lists.
Yes, but I will not use reduce. NumPy.
Okay, so let's leave the MapReduce lambda functions. Yeah. We need to talk a bit about is and in and how this works before we move on. So this is the next to last example before we're actually done with the basic syntax. Start a new file and let's do some experiment with is and in. And let's talk about the results. So start with writing these 6 lines.
Oh, okay.
And then probably you directly understand what in and not in means. So actually, maybe we'll skip the practical task. Okay, everyone's still furiously typing, so I guess they're not done. Okay, so let's talk a bit about the in is a logical operator, can you say, because it returns a Boolean, so it returns true or false, and you are checking if the object h, in other words, if a string with the content h is in the data structure A. So if there exists an element somewhere in A that's a string containing H, then it's true. And not is the Boolean equivalent of negation in Python. So this checks the opposite version. If A does not contain an object of type string containing G, then it does this. And if I would have put a space here after age, it would be false, because then the strings are not the same anymore. And also, this in word, a keyword, also works with dictionaries. So if A would have been a dictionary here, then it would look for the key H. It wouldn't look for the value H. It would look for the key. So this is a really, really good way to check if a dictionary contains a key. Any questions about it?
If A were a dictionary,
Yes.
so with round brackets.
Yeah, the curly brackets.
Yeah, curly brackets.
Yeah.
Okay.
And then it would check H against the keys and not the values. Okay, so the next couple of lines. So if we do B is equal to A, let's talk more about what that actually does soon. Let's initialize two lists, each one element list with just the number 0. And then we will check this equals, which is equivalence, the equivalence operator in Python. So what does line 10 return? And what should it return? Yeah, it returns true because they're both lists containing exactly 0. Exactly one element, and that element is an integer 0. So the lists contain the exactly same thing. How about line 11? What do you think that would return?
False.
Yeah, it returns false. Anyone have any idea why?
Yes, of course, because it's C and T.
Yeah.
C in one place and T in another place of memory.
Yes. So even though the contents are identical, the contents are actually stored in different places. So it's physically not the same.
So if you're talking C here, it means that line 10 says what the pointer is pointing at, while line 11 says what the pointer address is.
Yes.
Okay, thank you.
If we talk about pointers. Yeah. So I will not have time to actually talk about pointers in depth and what they are and how it works. But
We have passed that level 20 years ago.
Okay.
Talking about pointers.
Yes.
Come on.
It usually takes an extra 1 hour if I even start talking about pointers, so I won't do that. No. But
I mean, from the logic, equal to values to calculate in one
Yes.
compare, and it's easy to understand when you need that logic.
Yes.
If sounds more like you have lost your track of your own variables rather than.
It's not that difficult to do.
No,
Yeah, so
But C is D would only return true if C and D would be pointing at the same memory location.
yes. And that's why, what does line 12 return? True. True. Which is really dangerous. Can someone tell me why it's really dangerous that line 12 returns true?
Because line 6 is setting the pointer B to the value of the pointer A.
Yes. So that means that when we did this, we didn't actually copy any data. B and A points to the exact same data. So if you change B, A will also change. And that's super dangerous.
It's also pointless, isn't it?
No, it's extremely useful.
It's super useful. But the thing is that you have to be aware of it.
I mean, why? Essentially, you could just keep using A.
Not really.
Okay.
Yes.
I'd be interested in here.
To be complete, how would line 6 look if you copy the content of A into B?
Dot copy. Kind of easy.
Yes. Yeah, it works like that.
All right, we also try the A brackets colon. would work too.
Yeah. Yeah. So if you do yeah, actually we can do that without the library. I'm going to talk about it later, but there are a lot of ways to copy the data instead of just assigning the pointer.
So basically, yes. If I now would attribute this one and then I would do a change so that I insert a new value to B, I would also put the new value to A.
Yes. So this is also useful for actually checking this. And if you do, so as I talked about before, what do you want to do?
So what I actually tried was this C equals A.
Yeah, colon. Yeah.
In that case, C is not equal. C is A.
When you copy the context, you copy the context to a new location.
Yeah. We will talk more about this soon because we will go through. I have a few slides about shallow and deep copies, and then we will write an example that goes through all the 3 different levels of it, because there are 3 levels of doing copies like this. Either we can do this level of copy, which I would say is the first level. Then we can do a second level of copy, which is what Fredrik did here. And then we can do a third level of copy, which is a true copy that copies absolutely everything and make sure that everything is copied. So we'll go through how this works later. Questions so far? Now, it's the last 3 keywords, and this will be really quick. So it's pass, break, and continue. Pass literally means pass, don't do anything. It just says, I'm empty.
It just says, I'm empty.
Yeah, I'm empty, don't do anything.
The reason why it even exists is that you have indentation.
Yeah.
In C or something like that, you would write curly brace open and close, and that's it. But you can't do that because what's an empty block? It's just nothing. But yeah, I mean, you need indentation. So pass is pretty much the word saying, here nothing happens.
Because
you
if
can
you
skip
just,
the first line in the first place, right?
no, if you remove this, you get syntax error because it doesn't know what indentation to attribute it to. So it needs to have an indentation and then an identifier that says there's nothing here.
Like a phantom in LaTeX.
Yeah. And then we have the continue keyword here inside the for loop, and we have the break keyword here also inside the for loop. So write this for loop, and just looking at the output, could I have some reverse engineering of what the continue and break actually does? Yes. How many here has program C? Yeah, okay, 2 or something. So
What's the difference between a pass and a return?
pass is nothing. Returns actually return something.
Could you have return empty? Could you do that?
Can you return an empty tuple, right?
You can't return an empty tuple, but you can just say return.
And then it's none.
Exactly.
Yes. So you return none then.
If you return none,
Yeah.
not none, if even.
Yes. No. A function always returns something. And if it doesn't return anything, it returns none implicitly. So even that function, I'm empty, will return none.
Okay.
Okay, so it returns
But
none.
you need to pass occasionally if you want to write something like, if this condition, well, actually do nothing, but else do something. And in this if block, if you want to write something there, then you write pass.
There's like a continue in a program.
But in this case, is it possible to replace continue by pass?
No, because then it's not doing what I intended to do. Because I wanted, so here I wanted the continue to skip this print.
Continues is.
Which you should see by looking at the output of
this.
this.
Is again because I don't understand the way if this end.
Yeah.
Yeah.
So if ended when this indentation ended.
because for me it's much more easier, of course, to understand that if and if, if for and for. And when it's without and, it's quite difficult to do it. Yeah.
So can I replace this continue with pass or not?
If you replace it with, so maybe I should explain what continue does first. Has everyone gotten this to print something?
Yeah.
Okay. So let's go through the loop one after one. So I is 0, print 0, do nothing, go here. I is 1, print 1, do nothing, go here. I is 2, go into this one and execute continue. Continue means stop executing this code block and move on to the next iteration. So skip this part and put I to 3 and continue. So I is 3. It skips this, prints 3. 4, print 4. 5, print 5. 6. Skip. Jump in here, break. That means skip the rest of it and jump outside the for loop.
What is the function? What is the line 11 doing?
It's calling this function. Do nothing. Which is doing nothing. Just to show you that it's actually doing nothing. So this is some basic program control flow things. If you want to continue an iteration or break the iteration, it's two very useful control loop statements. And it also works in while loops. So, any questions?
Then that if I like the same thing, but I don't know.
So now that we're done with that, let's do a recap. We've gone through all of these. We didn't explicitly talk about Booleans, but I assume that everyone here is familiar with them. Yeah. We talked about tuples, lists, and dictionaries, and we didn't talk about sets. Sets are basically data structures that are unordered and have only unique elements. So it's a mathematical set. And that's also useful, but we're skipping that for now. Then about the keywords. We went through for and while, if statements, function definitions, lambda functions, is and or in, pass, break, continue, false, true, none. None between means nothing. We didn't talk about this, but again, for those who program in C, this is, I guess, the closest thing is void. So try, except, raise. I don't think we will have time to go through this today. So if you want to, I have a lecture slide in the material that's called debugging lecture, where I have some examples and go through how this works. And this is really useful to develop programs that basically debug themselves. And that's how I recommend you to develop code. Write code that debugs itself as much as possible.
How about writing code by the code itself?
No,
Not yet.
no, not yet, at least. We can only hope.
Oh, that's not. You know how debugging works when you haven't written the code?
Yeah. Okay, so, and then the with keyword, this would have been a practical task, but we don't have time to do it today. So let's just skip that. And let's talk.
Is the practical task in your slide so we can do it ourselves?
Yeah. So I would say do the practical task on your own the coming week or something. And we'll skip classes because it's way too big a topic to talk about today.
I tried this if in list. Then I tried to for the dictionary, but it didn't work. No, if then I think quotation and bracket, the number bracket, then quotation. You know that you yes, which one? Like this one.
Then so now you should look for the key.
No,
Yes.
not the.
Not value, key.
Not value, not the key. Okay.
Yes. So key. Okay. So the practical task, I will just explain the task for you so that you can try it. So in this file structure that you got, there's homework 1, which is it was the student's homework, and there's just a file there which just has a function with paths. And the function is called run logistic, and it takes 2 input numbers. It takes R and num. And this is the equation for the logistic map. So it's an iterative equation. So you start with an initial condition, which has to be 0.5 in this case. And then you put 0.5 here, 0.5 here, whatever R you input to the function, and you get a new one. That's step 1, x1. x2 is the same thing, but you put x1 here, and so on and so on and so on. And what you're supposed to do inside this function is just return a list with all iterations between 0, which will always be 0.5, and num. And num is an integer. So if I put 5 there, it will be a list of length 5 containing 0.5, and then whatever this returns with the value of R. And so on and so on and so on, until you have reached 5 iterations. Super simple.
What is R?
Just some constant.
Yes.
Some floating
Okay.
point value.
In this equation.
Yeah.
That's very simple.
So this is just for homework. Do it later. And when you've written this function and you've returned this list, you can just run this program, plot logistic. And it will do a really nice plot of the function, and it will do a parameter sweep of R. And it will show you something called the bifurcation diagram, which is one of the earliest discovered paths to chaos in deterministic models. So that's a really cool history example, as well as science done in just 3 codes of line, basically. So do this at home or later or whatever, and we'll move on just to get through the lecture. Okay. You can also do these next ones if you have time. The practical tasks. It's all the instructions are in the slides, but what I want to show you is just this thing, which is in the, let's see, where did I put the file path? I put the file path here. So the folder is practical tasks, and then task one. There is a few data files. There is a data1 DDAT and a data2 DDAT. And the task here was to read the data from data2 DDAT with a for loop, and then calculate the mean of every column and calculate the standard deviation of every column. And then again, once you've written that function completely, or completed the function, you can run task1 test.py, and it will actually go through your code and see if you returned the correct thing, and it will, if you have done something wrong, it will probably suggest what you've done wrong and what you need to fix. So this is also homework for you.
For the read function, how can we read it?
There are, just look at the slides, because I explain here how to do a read function. So just look at the slides. We don't have time to talk about this now. We're like 1.5 hour overtime. Okay. So. Okay. Now I can finally go to part number 2. Any questions so far on part number 1 before we move on? Or are there just a million questions? I will be crowded next week in my office, I feel. Yes. Okay, let's move on. So I will not do all this. We will probably cut the lecture here. But we will talk a bit about modules. I'll skip the classes. I'll just do one of the slides and talk a little bit about applications and uses. And then we'll talk about libraries. And then we will also talk about the Influential copies here. And then we'll do some specific stuff with NumPy, Matplotlib, and SciPy. And then Sutana should come here in a while and talk about IRFPy. Okay, so modules. When we did the import NumPy as n, that line to get all the black magic with random numbers, that's what we're going to go through now. So what is a module and what's this importing? Well, I see it as an organization of Python code. How do you organize your code in a nice way? So for this example, we have a file called functions.py, which contains this nice function that takes a list and prints it in a formatted way. Doesn't matter what this is really, but it's a file that contains function. And then in this file, which is called main.py, which is in the same folder, we do import functions. And then Python knows to look for a Python file which has the name functions.py. It takes and runs all that code in that file and binds it to the name functions.
But it doesn't need to be functions, it can be amplifier or something else.
Yeah, it can be variables and all sorts of things. So to call this function, we write functions.printlist.
Because there could be different definitions in this function.
Yes. Does it make sense? Okay. So there are two different ways we can do import. We can write import function, or we can do a from version of it. So we can do from functions, and then we import one specific thing. So we say import print list. And then print list ends up here with just the name print list. It doesn't have to write this functions dot anymore. And we've just imported one thing. So everything else from functions is no longer available in our scope. It's just this one thing. But all the code in function has still been run.
What last? What did you say last?
That all the code that's inside the functions.py file has still been run. So when you execute this line, it actually runs all the code there. So if you have,
it takes, all print list is needed.
Yeah.
Okay. It's faster, simply.
So then we can do something else. We don't just have to import one unique item from this. We can actually do this. We can use a wildcard here. And I put a comment danger here because that's what this is. This is super dangerous. Because this means import everything and just put it into my scope. And if you don't know what function contains, you could accidentally override half the functions that you already have defined. Or you could get a bunch of junk that you didn't need. But then again, there are applications. So this would work, and you would be able to access print lists in this case. But if there was also variables defined here, they would also end up in the scope with those names. So one application I've seen where people have used this wildcard syntax is just to do a quick configuration file. So they just have a file where they put a bunch of variables to numbers or to configurations, and then they just import all the variables that they need to run their script that way. And that works. But again, it's kind of dangerous. So be a bit careful about using that, but it exists. Any questions?
You would not have this problem if you do it the other way around, that you just start with functions and then you start your main.
No.
You would not have this dangerous situation that you write over.
No. Unless, actually, that's happened to me. I imported some library as with a name, and then I actually used that name as a variable. And then I didn't understand why I couldn't access the function inside the library. It just told me that the library was a string. I was like, why? It's not a string, it's a library. So, and yeah, so you still have to sort of keep track of names. And that's where the next keyword comes in, as. So as works as a renamer, you rename it. So if you do from functions import print list, and then you write as p, it basically renames this. So then you can do p of l to just print the list. So it's just to be able to rename stuff.
And if you had done that with your list, in your example, then you would not have written over your list that you were looking for.
Yes.
But for this S, can you also put several functions there, or can you only put one print list as p? If you have
Does it work with
p or read list or whatever?
I don't think it works. No, it doesn't work. I tried it a while ago. Yeah, it doesn't work. You have to do one.
So if you want to rename several, you have to do it one line each.
Yeah, which is why it is, if you want to have several functions from a library or a file, it's generally better to do this instead. So you do import functions as f, and then you have a very short name to access all the functions inside it instead, which is what we did with NumPy. So here, we just did import NumPy as n, and then we started accessing stuff inside NumPy. NumPy, however, is a little bit different because it's a package, not just a Python file somewhere. And we'll talk about how a package is structured, just so that you understand the hierarchy of how it works. But this is exactly what we did before. So we imported NumPy as n. We accessed another sub-library within NumPy, which is called random. And then rand is actually a function somewhere defined inside NumPy. So somewhere it says def rand. And then there's a bunch of code.
What is the dot close? When we import that immediately after import that for example the matplot then the PLT the PLT close and the O. What that means?
I have no idea.
Okay.
That was some matplotlib specific thing. So yeah.
Okay, not.
Yeah. Oh yeah, it closes all the Qt inter whatever. We don't need to talk about
okay.
Yes. Okay. So I said with this example that functions.py and main.py had to be in the same folder. That's not actually true. They have to be on what's called the Python path. So a way to get around that, so that you don't have to put everything in the same folder, which is horrible, you can either do packages, which we'll talk about after this, or this is something that you can do. So sys is a package that has to do with everything about how the systematics of Python and the interaction with the operating system works. It contains a bunch of useful methods and data for that. And one of those is the path. And that's all the locations where Python looks for files to import. So if you, for example, do insert or append, you can add a file path to this list of file paths. And then it will also look at this location for Python files. So if you, in this folders, let's say I have home, my username, some folder, and then something called a package. And then inside this folder, there's a file called mylib.py. Then this code would run, even though this script is anywhere on the computer. Then it no longer has to be in the same folder. And then there's also a library called OS, which is for the actual interaction with the operating system. But we'll talk a bit more about that later.
Is there a way to see which functions are in this sys.path?
Yeah, you can print the sys.path, I think, right? Yeah, you can just print. Just do print sys.path, and you should be able to.
It's actually just an array, just a list.
Yeah, it's just a list of strings.
You don't know what's in the.
No, what I mean, it's just a list. That's why insert works. It's just the exact same thing as list. So you can also just print it. So you can import. Actually, you can try it in Python right now. You can import sys and then do print sys.path. Then you know.
And then you see all the places where Python will look for files and packages when you write import. And you can edit also. You can edit your Python to have certain paths as default, so you don't have to do this in every script. But you can look that up for yourself on the Python documentation. Okay, so I've been saying that packages and files is not the same thing, and I'll talk more about that now.
Can we have a short break?
Yes. When do we have coffee break?
Now.
Now, okay. Do I have, okay, so this is, yeah, okay. We'll do this after the coffee break. So after the coffee break, we'll talk about.
Do we take now? That's the next question.
Do we have coffee outside?
Yeah.
Yes.
15 minutes. So quarter two. Yes, and then we'll talk about packages.
So I have all import OS. Is that the same thing that we import OS and this import sys?
It's not the same thing. So sys is more about the system of how Python and the operating system interacts, and the systematics behind everything, while OS is an actual link to the operating system. So with OS, you can execute commands like rm or make dir or.
Because I'm running the Python using the same folder and it is running.
Yeah, it's probably put somewhere as it will.
Yeah, okay, probably, yeah.
Because you can edit it. So.
Yeah, probably Anaconda can do it.
Yeah, Anaconda.
Yeah, Anaconda can do it. Yeah.
Oh. Can I have a bed and lie down somewhere? I'm super tired.
Ja. Do I?
Finns det på armarna?
Ja.
Ja. Oj, finns annan kaka. Blir det för mycket? Nej, det är bra. Jag tror att det är bra. Okay.
Folk vill ha en krasch.
Jo, jag tänkte reduce.
Det är så.
He was working before.
I don't see it. I don't see it. Okay. Yes, it does. What is? Can you clear the SSH control in .png? SSH control, we just event it. And drop the last line. Okay, now try error. Try SSH add again. To list. Okay, now try again to SSH. But you killed the agent already, and you said that. Wait, you don't want to kill the SSH agent, that doesn't help. You have to kill the GPG agent.
Yeah, that's what I'm like.
Okay.
We have a new agent. It was a major disaster. I kept installed before.
Use Fortran and Mac.
Yeah. I'm Fortran master.
You took MATLAB. You took MATLAB.
I named Fortran program and then I gave up. I have also nice matter, but I'm very bad at the handling the file. The reading the file, I'm very bad at.
In MATLAB? Oh, there's a different
So because how to define the MATLAB file is difficult. Quite often the file type that is much when I try to calculate. So the idea
you can use
MATLAB is using only for simulation.
No.
そう、何が問題かというと、you are unique. Yeah, because you know the flag of the time to remind that it's just together about that this thing that's back together and now I get that.
Och lägger upp ett ord för ett sånt datum. Jo.
Good enough. Yeah.
Yes.
Very good. Hot man.
I think we made some good ground today.
Sorry, I should have started this 20 years ago. I'm feeling too old for that.
I mean, this is the, what is it, the 5th or the 6th programming language I learned. So when I learned Python, I just sat down with the manual for 3 days and just read the manual non-stop for 3 days. That's what I did.
It's quite a general language now in student, and you use its basic language.
No, they switch between Python and C, depending on the space.
Python and C.
Yeah,
it's not confirmed.
No, the space physicists do C, and the computer engineering people do Python, which is super weird,
But this is incredible. This
yes,
should be opposite. No, not opposite, but
not opposite.
Yeah. Okay.
But it makes sense that the students learn C because they should know how pointers work.
I'm for some person, you know.
Yes.
Of course, we use pointer, but in principle, not so. Okay. Yeah, of course. If you will solve the problem with if you will solve some linear system for linear equation, huge system. This case point is very useful. Yeah, that's right.
Just as an example, if you have a propagator and you have a propagator function. And then you have a matrix or a data structure that contains 100,000 objects that you want to propagate. You don't want to copy the data every time you propagate.
In this case, you can use splice matrix mathematics.
Yeah, but that's the same as using pointers.
But it's
It's already exists. Yes. But it's the underlying.
That actually is similar to Python. So I hate C
then
from
you have
Martin's point of
references.
view because when you try to work with multi-dimensional array in C, this is incredible.
They've actually gotten good at that now.
Yeah, but in any case, it's
it was horrible before.
Yeah, well, before it was not possible.
No, yeah, it was, but it was nice.
Yeah.
I actually, when I did my first solar system integrator, I had to write my. I completely from scratch wrote the n-dimensional array definition for C. And it was like, I don't know, 100 times faster than doing it the cumbersome way. And then they came with this update where they actually had proper multi-dimensional array handling at C. And then that was 10 times faster than my code. So
Okay.
Okay, last leg of the marathon. We talked about importing files and accessing those files through the handle and the contents of those files. Now we'll talk about a package. So what defines a package? Well, it contains a file that is named __ init __ .py. So if you have a folder that is called my package and it contains this init file, when you write import my package, it will run this init file and do a bunch of things with all the other Py files, depending on how you wrote this init file, and compile it all into a package for you. So this is a way to organize an entire file structure, not just one file, into one of these import statements. And then, of course, you can have directories with an init file inside this to get sub-levels of it. So
why would you want to import things in the first place? What does this import do?
So NumPy, for example. If you want NumPy, you write import NumPy. And NumPy is built like this.
If you want to use the same long function with a very long definition for the different program, then you make your own.
Yeah, and then also, so for example, a really good reason to do this, and something that I'm writing right now, is I'm writing a library, my own library, that's structured like this, that contains all the conversion functions that I use from different coordinate systems that don't exist somewhere else, and those that do exist somewhere else, but are very complicated to use. I wrapped them up in some code and made them easy to use. And then, in all my different science projects that I need to, let's say, convert longitude and latitude into azimuth and elevation at some other longitude and latitude, I can do that. And then I just write import and my package, and I get access to that function.
And that I can access that function, right?
Yes. And someone else might be able to access that function. And if I find a bug in it, let's say that I accidentally swap the X and Y axis, then I go, shit. Now all my data is wrong in all my 3 projects. But I just changed that function once, and it will update in all my projects. So you don't have to rewrite it everywhere. And again, this comes back to software development rather than just programming. Solving the problem of doing this coordinate transformation is one idea, but actually writing the coordinate transformation in such a way that you can use it in 3 projects is what makes life simple for you. So let's do an example about this. So let's reduce this bunch of files I had as an example, and let's just say that I have one folder called pack with an init. And in this folder, there is also another folder called sub, which also has an init file. And these files, so pack init contains this code. First, we'll talk about these 3 lines first. First, we define a function which just returns bar. And then we define x is equal to 5. And then what this line does is says that from this folder that I'm in right now, import sub. So it looks in this folder for something to import called sub. And what do you know? There's a folder with an init file, so it knows that it's a package. So it imports this package and binds it to the name sub. And in this, we have another function, which is called bar, which returns foo. Yes. And y is equal to 2. Okay. So now we have the file structure laid out and what the imports do. Let's see what it actually does. So now I have a Python program somewhere, and I assume that this pack folder is on the Python path. So I can just write import pack, and it will run this init file. So if I do pack.foo, which remember is this function, it prints bar, just as we would expect it to do. And if I even do pack.x, it actually prints 5, because we have defined the variable x inside this package b5. And since I here imported sub, in this context, there is a package called sub. So, no, that's the wrong way. So if I do pack and dot, that means I access the context of that file or the scope. And then I do sub. Then I go into the sub library. And then I do bar. And it returns true. So this bar function is the one we defined here. And here we also had y is equal to 2. So we can, of course, also access y as 2.
In the previous slide, the dot in the import is the current directory. But is that the current directory where that file is, or is it the current directory as seen when you call that?
It's the current directory where the file is.
Yeah, so it's not confusing.
Yes. Yeah. And you can also do, so you could omit this and do both, the imports here. But I didn't go through that because, yeah, I think this is simpler and less convoluted. Okay, any questions about this importing?
The external y are not defined. It is outside the defined sentence.
Yeah, pack.sub.y is defined, but y is not defined.
Not defined.
Yeah. So you could say that actually the name for y is this.
Because it is into Py file, it writes down.
Yes, so it trickles down the hierarchy. Any questions about this? I see a lot of confused faces. Does it kind of make sense that you have this folder, init folder, and then you can just access the names by doing folder name dot whatever's in that file.
Can you access Y directly? Do you have to specify the entire path down? I mean, via sub.
Yes, you have to specify it directly, unless you do one of these from Blaha Blaha import. And now that I've explained this, maybe this makes more sense. So N is NumPy, and then within NumPy, there's a completely own sub-package that's everything in there is oriented toward random number generation. So we do n.random, which is exactly what happens in this example. And then we access a function.
So random is a random pi, and then the random is a file that defined inside the random file.
Yes, and so rand is the function inside that.
In principle, you could. So Sn is just to get the shortcut for alias or whatever.
Yes, it's just.
Otherwise, you would call it with numpy dot something.
Yes. Otherwise, it would be numpy.random.run. And I can tell you that I constantly keep multiple pages of the NumPy documentation open, because there is no way that you remember everything about all the functions. So just keep the documentation open and search the documentation wherever you want to find something. And it's the same with SciPy. SciPy is like an order of magnitude bigger than NumPy. So it's impossible to remember everything that's in it. So just use the documentation and find what you need. So, and that's why it's also impossible for me to tell you everything that's in it. I will just give you a sample and an overview. Okay. Classes. We talked a bit about classes, how everything is really a class or instance of classes. And I just want to say that I just thought really long and hard about how to make this as short as possible and understandable. And my idea of explaining it is that it allows you to define the basic building blocks of your program. So if you have floats and integers defined, then all the rest of your code will just make up manipulations of floats and integers. So if you have nothing else, that's what your program will consist of. So if you just have floats and you say, well, I always use two floats together all the time, also called a complex variable, then maybe it's really, really annoying to just use two floats all the time. You just want to maybe use one variable name for two floats. So then maybe you write a class that uses two floats, but is called complex. And then suddenly the rest of your code consists of manipulations of floats and complexes instead of just floats and floats and floats. So it's a way to define the basic building blocks of the code. So if you ever, when you're writing your code, if you ever go, this is really annoying, I really would like it if I could just encapsulate this into one little thing and manipulate that instead, you probably should write a class. That's sort of the most quickest way I could figure out to explain it. Did that make sense? Yeah. Okay. And also, this is why I argue that classes are useful in both high level and low level. Because if it allows you to define the basic building blocks of the rest of your code, so it can be really good in the low level, in the case where I said, well, two floats becomes a complex, that's super low level. That's like the very, very basic building blocks of the program. But it can also be very useful in high level, in the sense that if you define an API for a user, you want to give them the basic building blocks that they can work with your interface without having to see like the thousands and thousands of lines of code that's behind it that makes it work. you want the user to just work with your very, very nice small object functions, and they don't have to see what it actually does in the background. And then you can define a class for this. And this is, for example, what I've done in my ESA project. When we do space debris simulations, we have all the simulation mechanics, and it communicates with propagators, and it does a lot of simulations of hard target scattering and blah, blah, and we don't want the user to see that. So instead, we just have a class called simulation. And what the user does, it just manipulates this class called simulation. And it doesn't have to see all this background stuff of how it works. It can just run simulations and look at the results from simulations. So, and of course, you can do without using classes ever. You can just do functional programming too. This is a matter of preference, I guess. So my advice is to use the best of both worlds. So what I do is that usually very basic scientific functions and algorithms, I define as functions always, because I find functions really easy to unit test. I find functions really easy to debug. And it's also easy to give away to other people and not just give them everything clumped up in a class. But then I use classes for basic structures, like this complex thing. Or I use it for overhead and APIs. That's just what I do. It's just my deal. You will develop your own style of programming when you start working with Python. There is nothing really right or wrong here about just using functions or using a lot of objects. I just wanted to talk about that before we move on. Okay. Libraries. So now that we know what libraries are, how we import them, we've used NumPy so far. So some of the basic libraries that I've used a lot in Python that you don't need to install, that just standard, is time. Obviously, concerns time. You can use it to get the wall clock of the computer, and you can get clock cycles with that too. I think you can get clock cycles, right? Yeah, I think you can get clock cycles with time. Date time is more about dates too. So it has a bunch of these good date conversions, Gregorian, Julian calendar, blah, blah, blah. Then you have OS, which is actually an interface to the operating system. So with the OS library, you can actually execute OS commands. So for example, removing files, making directories, executing bash commands. All of this OS interaction. System is more, or sys actually, sys. We already looked on a bit. It contained the path for Python. Subprocess, multiprocessing, and threading are for doing parallel computations. And they also contain some queuing structure so that you can queue tasks to workers. So it's really good for doing, how do you say, real-time programs. And then we have glob, which is really nice if you do a lot of file handling, because it gives you a lot nicer, cleaner interface to listing files, searching files in directories, filtering for specific files inside your file system. So it's a really good interaction with the file system. Then we have unit test, which is really good for unit testing. Unit testing.
What is unit testing?
Unit testing is taking a very small contained unit of your code and testing it. So, for example, if you have a function that creates a coordinate transformation, you could say that, well, this coordinate I know will exactly transform to this coordinate. So you could set up a test to make sure that your function actually does that. And then every time you change something in the function, you run the test and make sure that nothing I changed broke my system. So unit testing is a really good way to making sure that small changes doesn't break stuff without telling it broke. Because sometimes when something goes wrong, it doesn't always say error, error, big red flag. Sometimes maybe it just changes a number somewhere, and on your plot you get this weird outlier that you then publish, and it's actually a, a programming error.
Again, if the code is very complex, what can happen is that you do not realize that there is a problem until weeks later you run into that particular situation, and bam, you have no idea where it came from.
Yes, that happened in the ESA project. Yes, I don't know how many files it is. It's like 26 Python files or something, and every one snits about, I don't know, 500 lines of code to 2,000 lines of code. And I mean, it's super complex. So having testing helps. Traceback is a library for getting tracebacks of errors. So tracing back the error to where it originated. Socket is for TCP/IP connections and doing internet communication or network communication stuff. And I could go on. There is lots more, but these are the ones I selected to use because I think these are the ones that are most useful to you.
I think one more that's really, really useful, but that's probably less on the sciencey side, but for Perl aficionados, there is RE, which stands for regular expressions. So if you do a pattern matching, that's the topic RE.
Okay, yeah, I should.
That's really super useful. Just saying.
Actually, I should add that to the list. Yeah.
So what's the difference between the math and the NumPy?
Oh, math is designed to work on Python native data structures, while NumPy math functions are designed to work on NumPy arrays. So, for example, in math, there's an absolute value function, and there's also an absolute value function in NumPy. But the NumPy absolute value function is designed to work on the sort of C-based data structures that NumPy uses. So it's optimized for that, and it works fast with that, and it works as you expect for that. While the math library is made for not using any other data structures than the native Python.
Okay, then if we import both, then we just write an absolute, then fit function will be called the first.
Yeah.
Fit will be called, if we import both.
So then one is math.abs and the other one is numpy.abs.
To specify exactly. And how about the pandas?
I'll count it here. Okay. Here, pandas. Okay. So specific libraries for science. So SciPy is a large collection of, it even says ecosystem. So you know it's large. For math, science, and engineering. And it contains NumPy, SciPy, Matplotlib, IPython, SymPy, and pandas.
Oh.
So if you install SciPy, you get all of those at the same time. And NumPy we've talked a lot about. I'm going to go to more of that. Matplotlib is fundamental plotting library. There are some alternatives, but you can look that up on your own if you need an alternative. SumPy is for symbolic mathematics, which is pretty cool that you can do in Python. And then you have pandas, which is an alternative to the native NumPy data arrays, which uses another data structure and some analysis tools. And then Some useful libraries that are not included in SciPy, or at least that I find really useful, is PyProi, which does cartographic transformations. So if you have an instrument somewhere and you have its GPS location, with PyProi you can convert it to Earth-centered, Earth-fixed coordinates and do all your nice data analysis. AstroPy is common core package for astronomy. It has all the standard astronomical functionality. Pillow, image manipulation, contains filtering, Gaussian blur, reading of JPEG and PNG and all the file, everything that has to do with image manipulation. Then you have MPI for Pi, which is one of the best discoveries that I made in Python. It's MPI stands for Message Passing Interface, and it's used in pretty much all computer clusters that I know of right now. They have support for MPI. So that means that if you write a Python script with MPI, and MPI is super easy to use in Python, you can just upload that Python script to a supercomputer and it will work. And instead of running it on your laptop, you can run it on 1,000 CPU cores or something. So if you just look up MPI for Pi, you will get some introduction and some tutorials on the website. H5 is HDF5 file handling for Python. Also very easy to use. It supports NumPy arrays. So really the data sets you save as HDF5 should be NumPy arrays, but it doesn't support saving whole Python objects. So you should really convert your data to NumPy before you save it as HDF5.
Can you read any data format, or are there limitations? Can you write any data format?
With the HDF5?
Well, generally with Python, I mean, MATLAB has some limitations.
There is no limitations.
No.
Seriously, if there doesn't exist a parser for that file, you can write the parser. So
I can't read it, I can't write it.
So must be read fast.
So, but generally, if there is a parser for a file format, either there is one in Python, or you can wrap it in Python and make use of it, implemented in some other language like C or Fortran or something, and then just use it in Python.
Can you implement it here?
What file format is that?
But it's not a file format, it's a language.
NCL.
Mm-hmm.
I don't know. I've never tried it.
But, actually, I had several times reading a program. Even I generated from C program, and when I did something that probably that my definition of the function was wrong, but
so
simple.
There is a nice, clean way to interact with other programming language as Python, and that's to actually use a proper bridge between them, or use compiled libraries. But then you have the ugly version of doing it, which is just to run it through the terminal, through OS in Python. And you can do that too. If there is no other way to interface Python and the programming language, you can just create a compiled file and then actually run that compiled file through the terminal controlled through Python and then do it that way. But I don't know for that programming language specifically.
There is a PyNCL package list.
Yeah.
And then,
So this will be NCL.
Yeah.
Okay, and then we have some fringe libraries. I've used both TensorFlow and Gluon, and they're really nice packages. They're for machine learning and deep learning framework. And then Rebound is an n-body integrator for Gravity, which is also available as a package in Python. And then MATLAB. You can actually import MATLAB into Python. So if you write import MATLAB, you actually start the MATLAB engine inside a Python session. I don't know why. No, I don't know why you would want to do that, but you can. So.
Okay, so the deep learning framework is it?
Yeah.
Oh, good.
And also inside SciPy, there is functions for reading MATLAB files into Python. So if you have .mat files, you can read them directly into Python with SciPy.
Oh, that works without problems?
Yeah. Flawlessly so far. Okay. So let me skip this and go directly to this. So we'll do some Matplotlib specific examples. But first, I just want to show you this. So this is one of the most useful things about Matplotlib. Its gallery is huge. So on the website, there is a subpage called gallery, and I'll show you that right now. Here. So usually, when I need to do something in Matplotlib to plot something and I don't know how to do it, I just go here and then I do Control F and search for keywords that I know is similar to what I want to do, or I just scroll to the page and click on something that looks similar to it. It's not super, it's not like any fancy method of figuring out how to do it. I just do that. It's a bit lazy, but it works. So, for example, let's say I'm looking for something to do, plot several data sets into the same histogram. Okay, so let's go through here. Let's see if we can see something that looks like it. Here we have images and contours and a bunch of meshes. That's not it. Subplot, axis, and figures. Oh, wow, that's a lot of stuff.
You can't do that.
Statistics. Bar chart demo. Here we start getting into something. Here, demo of histogram function with multiple data sets. Okay, so let's open that. And then, did I lose internet? That would be so difficult. Yes, okay. So, and here is all the ways to do multiple data sets in the same histogram. And then down here we have the code to do it. So usually what I do is I look up whatever combination of stuff that I need, and then I cannibalize these example codes and put something together that works, and it doesn't take more than a few minutes. And it also has a very active forum, so if you have some troubles getting something to work, usually you can just ask a question or look up a question if it's already been asked and find the answer. Any questions about Matplotlib or plotting, or?
Do you know if they do actually maps? When you plot a map, I'm trying to search it right now.
No, what's it called? Map. There are 12 map. Oh, that's color maps.
Like a topographic map.
Yeah, it's projection. Projection it must be. Here. Custom projections, for example. Yeah, and it has hammer write-offs. And here is how you do custom projection. Oh, this is the actual code for everything. Yeah.
What's the URL of this site? Matplotlib.org?
Yeah, matplotlib.org.
Okay. And then, because Matplotlib is too big, that when we call we normally call as a function name instead of empty.
Yeah. All right. I wanted to show this too. Just to give you an example, this is something that I did for the simulation toolbox. this is just a function in Python that takes one of the files that outputted from my simulation and creates a movie of the solar system simulation. And this uses Python and matplotlib. No, my internet, why? Well, you saw the first 5 seconds. It's probably because the internet is overloaded. Okay, whatever. You saw the movie, at least a snippet of it. Yeah, well, don't care about that. Anyway, so yeah, I'll skip MPI4Py and I'll talk about shebang. So if you put this hashtag and then a line like this at the start of your Python code, this tells the program loader to use this interpreter to interpret the file. So here you could put Python 3, for example, or you could put so this is more for when you really get into Python and you want to specify exactly what environment, exactly what command should be used to interpret this file. This is a really a good way to do it. This is the only way to do it. For example, when you use MPI4Py, you have to have this here, because otherwise it doesn't know what interpreter to call to make sense of your program. So just for you to know that there is something called shebang and what it is. Because I've seen a lot of people see that line and then just remove it because they say, why is this here?
Well, actually, with this one, you can start a script like a shell script.
Yes. So it's more universal than Python, but
you need put execute permission also.
Yeah.
Yes. Yeah. But just as a comment. So I'm just trying to litter you with useful comments and bits of information that might prove useful. So.
But if you start a script within Anaconda or within Spider, then the editor opens up with this line and another line.
Yeah.
Of coding.
It does that automatically. Yeah. So, and then quickly, I'll just show you an example, PyPro. So this is, it's 1, 2, 3, 4 lines of code to perform a longitude, latitude, altitude coordinate transformation with the VGS84 ellipse into geocentrical VGS84 ellipse coordinate system. So this is basically from GPS data position to ECEF data coordinate transformer. And it's 4 lines of code in Python. So it's a pretty nice system to be able to transform coordinates when you do data analysis for ground-based observation systems. What's it called? Observatory things, systems. I'm too into programming right now. I can't language.
Do you any calculate the geomagnetic field mapping from the ground?
You could probably do that.
Are there any some library?
I don't know because I don't
have
do.
to find out somebody has already.
Yeah, but you could probably do it with this. Yeah. Anyway, now let's go into the whole copy thing. So now open up a new file and let's dive a little bit more into this pointer if A is B or not deal. So Now you have a bit of code to write, and then we'll talk about what it does, why it does, what it does, and how we will fix it to do what we want it to do. You don't need to reproduce the list of lists like with all the elements. Just if it's too much to type, do something similar. But you need a structure of lists of lists. Okay, so has a few people gotten the lists to print and also printed the ID of the lists? Okay, so first of all, what can you see in the printing of, actually, let me just tell you, ID is sort of a one-to-one fashion to map actual location in memory, like where it is stored, into a number. So instead of giving you actual memory addresses in the computer, it just turns this ID into a number and it says this is the ID of something. So what can you say about the ID of A and B? Yeah, they're the same. And this is exactly what we did this morning. When we did B is equal to A, and then we changed something in B, it also changed in A. And we can see this with the ID here, that the ID is the same. So it's pointing to the same place in memory. So here we changed something in B. That means it also changes in A. And here we appended something to A. which means we also append it to B. And when we print A and B, we have both of these changes in these prints. Everyone should have them. Okay. So now we can talk about shallow copies and deep copies. So shallow copies only first level attributes, and we'll see this in the next slide. Deep copy basically does a shallow copy but recursively. So whenever it finds something that points to a new memory location, it copies that as well. And if that memory location contains something that points to another memory location, it goes there and copies that as well. So it just goes through everything and makes sure that there is nothing left that points to the same thing, and just creates copies for everything. So now in this example, just uncomment or comment away this line, so this doesn't do anything anymore, and then import copy. And then do copy.copy. So it's just add this line and this line. So what changed in the printout?
Copy program.
Yes.
Okay.
Can you briefly explain what E2, 1
So
the 2 and the 1, what it point to?
So B2 is element 2 in a zero index system. So that means 0, 1, 2. So that's this list. And then 1 in a zero index system is the B.
Because I forgot that it was 0. So
Yeah. So we're changing this one to 36.
In my case, it shouldn't be in the, after this change, in one B there are B and the other one 36.
The 36
comes into A2.
Comes into both.
Yes. And that's because this copy is what I call the shallow copy. So remember how when we did this, we just made it point to the same memory location? This is also a list. So when we copy this, we are actually just copying pointers to these 3 lists.
Okay.
So these 3 lists still exist at the same memory location. And if you look at the IDs, now the IDs of A and B are different. But if you would do ID of square 2 or ID of element 2 in B and A, they would be the same still. So this is just does it on the first level. So this change, where we changed A, that only affects A. But this, where we actually access first the pointer and then change something inside that data structure, it changes in both.
It is exactly as you see.
Yeah. So now what we actually want is a true copy. And then we just comment this line and add this instead. So we do copy.deep copy. And what that does is that it basically runs copy recursively on all levels. It just keeps following pointers and copies the contents of that.
So what is the copy with Fredrik wrote?
That creates, that's a shallow copy. Yes. This is a shallow copy.
Mm-hmm. So if we just, okay, so even if we change the B, then it all automatically changes A. So if we have.
Yeah, if you don't do this.
Yeah.
So now this should only change B and this should only change A, ever.
So if you want to be really sure, you should always have a deep copy.
Yes. unless once you start getting really familiar with what your data structure is, what data structure you're using and how it works, then it's fine. You don't have to use this. But if you want to be really, really, really sure, I have started to use this just to make sure that I don't accidentally do something stupid.
What was the difference?
So when you added this line,
Yes.
when you did this change, you didn't change A this time.
Yes.
Yeah. No problem.
So anytime you want to copy one variable to another, you have to write all this copy, deep copy.
No.
No.
So for example, floats and strings, they do that automatically. So if you just have a floating float, so if I say A is equal to 3.5, and then I do this first one, it will actually copy it. It does a deep copy automatically.
Okay.
If you have strings, it does it automatically. But when you go into data structures, that's when you get into the carry part of it. So all the basic level data types, so floats, complex, booleans, integers, they just does it automatically. And you don't have to worry.
If I compare this to C, I think that it's easier to know when you're dealing with pointers in C than in.
Yes.
It's a little bit difficult to see. In C, you always know when you're dealing with pointers. Here, you could be a little bit confused.
Yeah, but once you know it, it's fine. You learn it, and you. So to get the precision that you have in C, you have to sacrifice so much readability and ease of use and everything. And I mean, that's why Python has exploded. It's because removing those stuff and just this is a very, very small price to pay. Okay, any questions about copies?
Also, copy, change the ID number, and copy, deep copy, change the content.
Yeah, it goes down the content list. Okay, so this, again, you can do the task 2. You can do as homework. Task 2 is about loading data and calculating the fast Fourier transform of that data. And then I put some useful commands here that you can use. So that you can do by yourself at home. So let's move on and talk about NumPy some.
Can I move to IRFi? I have a technical.
Okay, yes. So we'll skip and talk about IRFi.
It's basically supposedly the same level of the
So do you want to
category.
Oh, nice! I actually get to.
Yeah, maybe you speak too much. Yeah. So thank you, Daniel. That's really great challenge of an introduction for Python. And I just would like to show small number of slides on IRFi. This is a Python library or package by IRF scientists. Well, basically, so far, yet SSPT group apart, several persons are working on that. But basically, for researchers. So easy installation and no need of knowing details about implementation. I say how the code is written, just to use for sort of your work. That's basic idea. And maybe later, when you are fluent of this Python language, you can contribute some piece of code to be put on the library, and then it will be distributed easily within your team, with your student, or say with your supervisor, or even worldwide scientist. So it's a very, so it's a sort of IRF institutional, say, efforts for library. Well, that's sort of Python. Well, why we choose Python? It's maybe you know already. Daniel already sort of advertised why, so I do not repeat. So it's a summary. As I said, it's a set of libraries and applications. So it's also you can provide an application. Application here is it's some standalone program that can do something, some parts. That also enable boost start of professional scientific works with Python. Why we need this one? It's sort of well, no reinvention of wheels. It's every time software development start from hello world, and you start say getting string, printing out, blah blah. But also for scientific work, also say some kind of a structure or some workflow you have, and maybe experienced scientist, you feel that, and now I repeatedly implementing this algorithm again and again. So it's no more just one, let's say, one implementation, then reuse that, and your neighbor or your colleagues can use that. That's really great. And originally, we in SSPT group, we have a lot of space instrument projects, and a lot of space plasma physics, data analysis, simulations, and data analysis of simulated data, or say lab work, and a lot of data processing. But somewhat everyone is implementing the same code again and again and again. So it's a IRF project-oriented library, but without re-implementation. Well, we aim fully documented and fully tested library, which means that everyone can work without worry, concerns, but we have a limited resource, so it's sort of lab-on approach, we take. So sort of, well, as much as you can document for, say, users, and also tests. That's an automated test. So the code is sort of running always. And that's maybe this part will be next week. Code refinery workshop will address more. But we, IRF5, will already implement it say, in this whole structure development. And if we can use IRF5, it's basically everyone, it's open. It's not yet open source, I'm trying to do, but not yet done. But basically everyone can install, everyone can refer to the document, and maybe future everyone can download the code and source code. And basically we have a specific workstation, irf5.irf.sc, where all this IRF5 contents, including library, the package itself, and documentation is available. It's a big it's a summary. As I said, installation is very simple, isn't it? It's a single line command here. I don't know, PIP is not introduced yet. So,
no.
No, okay.
Since we went with Anaconda, we're not using it.
Yeah, it is a hybrid model, so it can work with Anaconda, but the PIP, it's an package installation, so that you must have it in Anaconda system already. So just install, and where it comes from. In the future, I will remove this one, yet, but anyway, currently we need this one, and a package name. It's an IRF5, and here use .util it is an IRF5. We have a lot of projects, but everyone is not interested in everything, so that we separate project into several. We separate and code into several projects, and then util it's basically a common library, top-level library, and option U is for update. But anyway, so this single line command will keep your IRF5.util package up to date. And for you who worries how to uninstall, just it's uninstall command is there, so you can just try. And if you don't like it, you can uninstall easily.
Can I call from can I import this IRF5?
Yes, exactly. I will. It will come. But then, maybe if you like, just do that now. But it does work, maybe. Network isn't working now. There is
You should do that right now, right away.
So this is available on the irf5.irf.se, so you can copy it from there, this command. You can go to that web page.
Yeah, right.
So for those who use Anaconda, you need to open the terminal inside of Spider to access the environment that you're working with. And it's in that terminal that you run this command. If you just run this in a console, it won't work. So you need to open up the terminal inside Anaconda.
How do we do that?
Or Spider. There's a console. I don't remember the. It should be obvious somewhere on the tool. Go down on the prompts.
Python package manager can only be used from outside of Python.
Oh, yeah. So you should do that in the terminal and not in the Python. So there's a different.
Well, I think you can do it on
Yeah, Mark to Mark, only in terminal.
So should I go to the IRF5 one?
Yeah, there you can find it and copy it.
I just go here and
You have to go my computer. So I have to go to
Just type this one as well.
You can just type on the
You mean, here?
Okay.
So how to test if it works?
Next slide.
Next slide will come. But if without apparent error message, that installation should be correct.
Is that the grant before IRF5?
Yes.
Grant.
No,
Yeah. Oh, that's the
and here.
Go to the web page
and
copy.
Unknown command install. I don't know. No marketing distribution found.
Anaconda från.
Ah, too much. It's successfully installed. Very good. On the light, you know.
When I open the terminal in, I don't know how the Mac version works. Where do you open the terminal in Mac?
The Mac I know how to open, but you need to open this in Python.
I don't know how Mac works.
Yeah, that's I know. Yeah, that, he said that you should also use this.
They don't even get this CMC. Oh, yes.
For Yama.
This one, yeah.
Ah, just for, yeah, okay. And then? Just do this?
Just to the side. So if you're using Spider terminal, then I think you need to reopen that. Or maybe not. I don't know.
No, you're saying we get open the terminal. Okay. Maybe we should.
Okay.
set up that time.
Yeah. Okay, so hopefully you can install it, and then, well, simple way of importing. So it's a lot, well, you need to import library, I mean, the package name or module to use this function. I mean, as for the case for other packages, the simplest way to find from IRF-lab import Asta. That is the easiest way to do, indeed. Then all you needed module is imported to your Python or IPython or terminal. This is very similar to sort of from PyLab import Asta, but it's used for Matplotlib if you know to use interactive plotting. It's really similar idea here. So if you can open IPython or what is Spider terminal or Anaconda terminal, then this one should work now.
So you wouldn't suggest that we use import IRF-lab as IRF or something that, and then we would access?
Yeah, that's a sort of more formal way.
Yeah.
Of course, import IRF-5.util, blah, blah, but for quick stuff, I mean, this is maybe,
Loading takes time. It's better to specify that. Say that library.
Yeah, exactly. Yeah, exactly. Some messages will show up, but
You need to calculate.
Okay, yeah, good. That's it.
To load all into the library.
yeah, but it's it means it's successful. It was successful so far. Okay, now one example of using IRF-5 util. Well, we have implemented some kind of calculation using a unit, physical unit. It is already imported as a name U after this IRFI import. So basically, its name U is a module for unit handling, say, for example, kilometer. And then this is a function NIT, but this is just unit, single dot, U dot nit. And then you can take an argument as 1738 kilometer, that is a radius of the moon, indeed. This R is a number of 1738 with a unit of kilometer. Then you can calculate the surface area of the moon by pi r square. It will be substituted as A and print A. You will get a surface area of the moon, just example calculation. And a unit of a kilometer, square kilometer. And of course, a unit can be converted to each other. So, well, if you want to know square centimeter, then use an rescale method, then you will get a square centimeter. So it's a very useful functionality for calculating a different mixture of a different unit system, for example. It's just an example. If you want to try, I will leave it. I will send you the slide later. So do you want to try?
Oh, it has a square simulator. Good.
No, it's quite useful. Well, this one is too obvious, but then if you want to calculate an velocity distribution function converted to differential flux, that's always confusing.
Use an arrow for me.
So that is the function U, and yeah.
It's in the module U.
Module U.
Or like in solar system physics, where they give all the units in terms of solar masses,
yeah,
velocity
exactly.
in terms of like,
or
like time in terms of
right.
parsecs and.
So that, of course, I can use that from here the lab import the U is okay. Yeah.
Yes. So if you want to calculate the mass in AMU or kilogram or
that's faster.
gram.
And then, well, it doesn't say kilometers. Why does it say kilometers?
I don't have
Oh,
Yeah, you need to.
Okay. Well, another example, you don't need to do this one because you need to install another package of I will just show an example here. Well, we are trying to make a coherent data reading of so far spacecraft data. Well, I call it a data center because most of sort of data analysis of spacecraft data start from reading data, which is the most sort of difficult to say. It's the most time-consuming part. So I don't want my student to re-implement every time when you want to read the data. So it's a quite important functionality here. But the idea is that, for example, this one shows several examples which will not work now for your system yet. But for example, Mars Express EMA data, it's an ion mass analyzer data. Similar data is in the Venus Express, another spacecraft. And Venus Express has an electron spectrometer. This is a different instrument. But Venus Express also has a magnetometer data. It's also a different instrument. But basically, you can see almost same way of reading the data. So, well, it's just sometimes specification. And then this IRFI MEMA raw data module have a data center, blah, blah, here. And then you get array will return a time and data as an array. But if you want to read the Linux Express data, very similar, but then a module is different, or package name is different, but then otherwise it's the same. Electron data also a little bit different module and data center in this class, this one. But this calling is the same, coherent, as well as the magnetic metadata. So basically, then you can read all the spacecraft data in a very simple formulation. So once you remember this statement, then you can basically read everything coherently. And for developer, or say for instrument provider, data provider like us, for example, then you just reading function you can make. Then put this data center framework. Then you can make a new data center that follows this get array, for example, command. Then so that we can extend this data reading framework to everywhere, or the available data set that IRF has, for example. This is a grand objective of this project.
So when I import that from ERF lab, the import ERF file. Import ERF file or import ERF NIMA?
This is just an example indeed. So it's not working code for your system, but in this case, you need to import irfpi.mima.raw data.
Okay.
But you need to install another sub package, not util. This is also an idea here. Still, IRFpi util has some modules. You can look for a document on the web page we have. Also here, it's a package. For example, if you want to data analysis of an Aspera, irfpi.aspera should be installed, and the data should be downloaded. That is a separate part. So Sara, it's our instrument on Moon, Chandrayaan-1. We have this package. Ika, it's Rosetta. CPEM, it's Jupiter co-rotation plasma environment model. It's another project. This Pixel, it's a PEP, it's a JUICE instrument on JUICE. And the operation system is in the package also. And then we have also a Flash simulation that Matt Holmstrom is implementing, and the data analysis of hybrid module, hybrid results is it's under development, so it's under package as well.
So ERFi is included in ERFlib?
No.
Oh, okay, yeah.
This is just an how should I say? There is an easier word, the syntax sugar. just to start, so that it's not a hierarchy. It's not hierarchy.
So it's not going to be that from ERFi import something like that.
Yeah, from irfpi.mima import raw data. From irfpi.util import UTC.
Okay.
That's really okay. Maybe this is a slide, and if you are interested in, please use that. And the feedback, please. It's quite sort of an interactive development. We do not have much resource, but so testing or say using and feedback is quite useful for us to develop further. And if you would like to include your code or say your application, then please contact me. Then I can merge it to a proper place, and then you can sort of install in your system another system or another system, yet another system easily. And also you can just give this pick command to others, and they can install that. So that's really brief introduction for IRFI, and I'm happy to collaborate with the IRF group, of course. And that's all. Any questions? Okay, thank you.
Awesome. Thank you.
Yes.
Not the library.
Okay. So we have like, what, 25 minutes left. So I will just very quickly talk about NumPy, and then very quickly talk about Matplotlib, and then we'll finish for today. And I urge you to go in and look at the slides, because there was not nearly enough time to actually go through everything today. So go in and look at the slides and do the homework, because you really need to actually sit down and do Python programming to get proficient at this. So NumPy arrays. So if you do n.array and give it a list of lists or a list, it will take this list of lists and create it into an n-dimensional data structure. So you can create vectors or matrices or higher order dimensional structures with this. This would, for example, create a 3-row, 2-column matrix in NumPy. And this is the way to initialize an array. And you can initialize arrays in other ways. But this array has a few attributes. So if you do a.ndim, you get the number of dimensions the array has. So this would be 2 dimensions because it's a matrix. If you do a.shape, you get to know what the shape of the data structure is. So in this case, it will tell you 3 rows, 2 columns. A.size is the actual amount of data points in the structure. So this would be 3 times 2, so 6, because there's 6 numbers there. And then we have this D-type. D-type stands for data type. So here, all of these were integers. So if I would do a.dtype.name, it would print Python integer. But you can specify other D types, and I'll show you quickly. And this item size, it basically tells you in bytes how much size does one of these items take up in memory. So here is an example of data types. So if I do this, I can say that, well, take this matrix, save it as a NumPy array, but save it as 16-bit integer. And then it will actually be saved as 16-bit integer. And if I do n.float64, it will save it as 64-bit floating point number. So if you print these two, this one will be printed as integers, and this one will be printed as floats.
Can you do calculation to change the format of the type?
Yes, you can do. So I would recommend when you do that to actually create an entire new array, and then just convert one data to another to make sure that nothing unexpected happens. So I would actually recommend copying the data over to an entirely new structure. But yes, you can do it. And actually you can, so for this constructor, when you do end.array, you can actually give it a NumPy array, and it will create a new NumPy array. So you can do it like that. So some types. We have the integer, the unsigned integer, floats. We can have float 64, complex. And if you go to the NumPy documentation, I think there's like 50 of these. You can go all the way up to float 264-bit representation. And you can have booleans and everything. And you can even have object. So you can save C-structured data arrays which contains Python objects. So that's pretty nifty. Some useful functions in NumPy. So if you do n.empty, you pre-allocate a matrix of this size. So this would pre-allocate memory for 2 rows and 3 columns matrix. And you don't know what the entries of these data points in the matrix are, because it's just empty. It just took a piece of memory in the computer and said, this belongs to this array now. And any data that was left there is probably still left there. So you don't know what it contains when you do empty. You have to get an array. If you do zeros, it makes sure that every value is 0 in it. And here I created something with 5 rows, 6 columns, and then 2 sheets in the Z direction. So a 3-dimensional array. And I stands for the identity matrix. So that's a matrix with just ones. And this is a 3-by-3 matrix. Ones, create the matrix with ones. This is a vector with 3 elements, where all the elements are 1.
Why do you have a comma in here?
Just to show you that it works. You can, if you write it like this, you specify that it should be just 1-dimensional. If you do 3 and then comma and then a 1, it says it's a matrix, so it actually has 2 dimensions, but one of those dimensions is just size 1. So there's a difference. And then linspace is a really useful command. It creates 100 points between 0 and 2 pi. You don't know the spacing, but it creates 100 points. And this is not yes, this is including 2 pi. While in n.arrange, you go from 5 to 100 and not including 100 with the step size. So that's the difference between linspace and arrange. This controls the number of points, this controls the step. And then in arrange, you can also add another optional argument, which is called include endpoints or something. Endpoints, I think it was. So if you write endpoints equals true, you actually get the endpoint too. So these are also functions you can look up on the NumPy documentation. Very useful. Yeah, so just to show you an example. Linspace, since linspace works on the NumPy architecture, you can also use dtype with that. So if I do a linspace with a dtype that's 64-bit integers, it will give me a linspace where it truncates every object that is saved into integers. So I will get 0, 0, 0, 0, 1, 1, 1, 2, 2, 2, 3. If I, however, set the D type to float 64, I will actually get the correct spacings between them and actually get the linear space. And if I do that in a range, these two are still integers. But if I do that, the D type of it should be saved as floating points. The array I get out is floating points, but with that set. So that's sort of how to control data in NumPy. And then, of course, it has a lot of math functions. So if you go to the SciPy documentation and then go into the NumPy, there is a NumPy for MATLAB users tutorial. So all of you who's super used to MATLAB, you can just go here and it tells you everything you need to know to get started in NumPy. And if you want to have a look at the math routines that are in NumPy, it's also in there in the reference document. So just to show you what I think is the most used is the multiplication of two arrays. So you can either do, so if A is a NumPy array and B is a NumPy array, you can do A dot B, which means A times B, or you can do NumPy and then access the dot and then pass A and B to that. And you still get the product. And dot is a really smart function because depending on what goes into dot, it changes how the function works. It either does scalar products or matrix multiplications, or just element-wise multiplication, depending on what you input there.
It is a very quick way to get some short info about such things without having the web browser. Just if you're at an interactive prompt, what is the fastest way if you want to just see what you can do with the function? Or
let's see. See if this works. There. Yeah.
You maybe want to move that.
Oh, yeah. Let's see. So let's plus this. So can everyone? Oh, Jesus. I'll do this. Okay. So here I started a prompt. I did import NumPy as n, and then I write help, and then parentheses the function. So if I write help and the function, it actually gives me all the documentation for that function directly in Python.
Is there a way to list functions?
Yes, but it's less trivial. So to list functions, you really should go to the website.
it is useful when you just forget what you need.
So yes, since Python 3, you can, instead of using dot, you can use the at operator. So basically it boils down to this. If you use star, you do A asterisk C, you do element-wise multiplication. And if you do A at B, you do matrix multiplication. That's basically how they boil it down now in Python 3, which is a lot more, I think, better to handle. So just to give you a few examples, here I've set up this example where I have two matrices and a vector, and then I do a bunch of operations on them. So let's see what this prints. So first, this is A, this is B, this is B transpose. So B dot T is the transpose, and this is the vector. And also, even though B is a row here, it's actually treated as a column vector. That's the only unintuitive thing that I've found so far about this. But this is just because the dimension of this is 1, and it just chooses to represent that as a row. And I guess that's also for readability. It's hard to read vertical stuff in consoles. So.
But if you define an array, say 3 times 1, and over here,
then it will actually be a row vector. So if you just define it as 3, then it just says, okay, this is a vector. And then it treats it as a column vector. But if you do 1, 3, then it's a row vector, because then it has 3 columns.
Is it the same way, or does it print it then as a...
It will then print it as, it will put an extra bracket here, actually, to show that. And that's all the only syntax thing that I found a bit confusing at first, but then it took 5 minutes and I was used to it. So, okay, so what can we do with these two? So let's do A times V. Remember, star was element-wise multiplication. So what it did when they did element-wise multiplication between a 3 times 3 matrix and a vector, it just took every row of the matrix and multiplied it by the vector position. So first index of the first number of the vector, multiply it by this column. Second element in the vector, multiply it by the second column. If we did A dot V, it will assume we are doing matrix vector multiplication and actually apply the matrix on the vector. If you get the same thing with the at notation. If I do B at V, since B is 4 times 3, it will project it into a 4-dimensional space, as you would expect. And if I do V at V, it will do the scalar product, because matrix multiplication between 2 vectors is a scalar product. If I do V star V, it does the element-wise multiplication with itself. Any questions so far?
How about V dot V?
That will perform this. Okay, and then if you use NumPy math functions on NumPy arrays, they will do them element-wise. So if I have an array that's 1, 2, 3, and I do n.exp of that array, it will take the exponential of each element. And the same time with cosines and absolute value and everything. And then also, of course, we have copies. So when we work with NumPy, we don't need to use the copy library. It's built into NumPy. So this is the first level copy. This is the deep copy, and view is the shallow copy. That's the terminology in NumPy.
So X copy is a deep copy.
Yes.
Oh, okay. X copy X array.
Yeah. And yeah, so what we would expect from this is that okay, yeah, let's not talk more about that and talk instead about matplotlib and basic plotting for the last 10 minutes. Yeah. So start a new file and let's write the last file for today. So save this as some, I don't know, basic plot or something. And now we import NumPy, but we also import this row. matplotlib.pyplot as PLT. And then after we're done, actually I have examples on how to do histograms, two-dimensional histograms, and also how to do movies in Matplotlib. So you can look at those yourself afterwards or some other day.
Why it should be an NP sign, not an ordinal sign?
Oh no! Sorry. Use N here.
And
yeah, not NP. I did syntax error. Yeah.
Yes, normally you go like the NP.
Yeah, I updated the example and didn't update my syntax. Sorry. Just remove this P everywhere. Yeah.
No.
Daniel, and what about graphic user interface? Is it included in this package?
How do you mean, like for zooming and stuff?
No, graphic user interface. I mean that doesn't.
Oh, for plotting?
Not for plotting, for everything. You make windows and you can button, menu, and blah blah blah.
Oh yes.
It's GUI.
Yes, there is, but that's not Matplotlib uses the library that does that.
Yes. So Matplot doesn't include this one.
Not in that sense. You can do it with Matplotlib, but a bit different. But if you want to do it generally, you should use something called Qt-inter.
Okay.
I will go through that on the third Qt-inter.
So I found TK.
Oh, is it TK-inter? Yeah, TK-inter. Jesus. Q. No, that's a totally different
Qt. Yeah, totally.
Yes. Oh yeah, Qt is a C++ framework.
But it has a Python library also. Qt.
Yeah, Qt has a Python library too. I use both TK and Qt.
Yeah.
But TK-inter is the one that Matplotlib uses.
So okay.
So does it matter if you put one string to save your figure? So do you need these two codes or do you need only one?
It doesn't matter.
It doesn't matter.
No, just a string with a file name. So this is to show you that you can save it as files. Super easy.
And
save it as
saved in the same folder as the program?
Yes.
Or you have to specify where it is?
If you don't specify where, it saves it in the same folder. If you specify a path, it will save it there. And I mean, most of these commands are pretty understandable. It's only this one that may be a bit mysterious, but basically what you do is you go to plot and then you start a figure that can contain any number of subplots that you want. So it returns a figure handle and an axis handle. And then on that axis you plot and you set stuff and you put there a grid on it. And then it's the figure that you're saving, not the axis. So it makes sense. And then this plt.show, it actually brings up the plot in a window. So
Average fee.
Yes, and now it's 16:30. And
Just one
people,
if you would have defined several figures and you had given an argument to plot.show which one to show, or
no, if you do plot.show, it shows everyone, or you can make it show specific figures too.
Then you blind.
But they keep them in memory, so until you do plot.show.
Nobody had no.
Yeah, so actually, who here needs to go with the bus? Okay.
Tima, can I go with you?
Yes, of course.
Yeah.
Okay, I can go with you. So only order is left stranded. So if you need to run to the bus, I would recommend you to do so.
Yeah, I will go in 5 minutes. It'll be fine.
Okay.
It's late anyway.
Det här gick inget bra.
Daniel, I need something. This line 7.
Yes.
This function has two output arguments.
Yes. It returns a handle to the figure
and
the axis.
Okay. That was my question. The previous question.
You can actually,
in principle, it's possible to make the function with any number of output arguments.
Yeah.
It's simply in return you put different arguments.
Yeah.
Okay.
So if you just do this parentheses and then comma, it will return it will actually return the tuple.
This is my question.
So the return to this is actually a tuple with two elements, and then when you do this,
but in principle it's possible to write this as two different variables.
Yeah. And then you get it out like this, or you get it as a tuple.
Okay.
And you can also split up the creation of the figure with the creation of the axis.
Yeah. So this is so.
Jag fick någonting att gnälla på något som heter TK-inter.
Har du startat terminalen i med X? Ett stort X?
Jo.
Om du har gjort det borde det fungera.
Så jag kan skriva.
I think I have defined PLT.
Det är inga problem att starta X-grejer, men jag har fått en hel
File, did you define import it was pipe?
Ja, det var ett fel. Felmeddelandet var inte.
Okej, jag förstår.
Det var en sida med felmeddelanden.
För när den klagar på TK-inter så brukar det oftast betyda att konsolen inte har startat med X-applikationen.
Men jag kan starta, om jag skriver extern här så får jag upp en X. Så de borde kunna göra det. Jag kör Python 3.6 så 3.7 funkar inte med Python, då får jag inte in min nummer 3.
Men om du kör den till SafeFig och sen så kollar du om PNG-filen. Så PNG-filen borde ha blivit skapad ändå.
Modul not found there, no modul named TK-inter. Import TK-inter TK kommer det på slutet. Är det något, ska man installera TK-inter?
Det borde bli automatiskt installeras med Mac. Men du kan testa och ta install install Mac. Och se vad som händer.
Ja, det händer någonting i alla fall.
So does this work?
Det är samma film.
you can save it as other. You can save it as JPEG and all the standard
you need a
formats.
different function for saving, or is it the same?
Should be the same.
Just add one line.
Yeah, just and also I think if you go to the documentation for SafeFig, you can actually specify compression algorithms and encoding and everything. And Pillow is really if you want to load image data. If you want to load image data, Pillow has pretty much everything you need to load image data.
And there's also legend, X, Y, and yeah.
So did everyone get a nice plot?
No.
No, except Urban. Actually, we'll have a look at that later.
Everything else is good.
So this is really the basic of how to do a simple plot in Matplotlib. And it also shows you like some of the nice things of how to use NumPy together with Matplotlib. So do we have any questions about this? Okay. I don't know, those who want to stay for a few more minutes. I have this basic histogram example too. So if you want to, you could just copy the code from the example you just did, copy it into a new file. And then instead of leaving subplots empty, we're going to add some stuff to it. Here we're going to say that we want one column of subplots. No, one row of subplots and two columns of subplots. So 2 plots. We want them to share the y-axis so that we don't have to draw the y-axis both times. And then we want to use a tight layout, so it compresses everything and makes everything really nice and smooth in the plotting. And then I just defined some number of points to generate and some number of bins. So I generated 2 a normal random distribution and then a dependent normal random distribution. So this would have a covariance matrix with off diagonal elements for those who do statistics. They have a non-zero row. And since we told it to create 2 axes in the subplots, this axis returned here will actually be a list of different axes. So when we do a hist, we want to do one histogram on the first axis and then the second histogram on the second axis. So then we go into the list and access the different axes that we created. And then I just added this. So you can keep doing this if you want to stack up multiple plots. Generally, it's good to make new names for these 2 so that you can go back and access them later in the code. But for this example, I just copied it. So here, I did fig and axis. But then I put 1 and 1, so this will just return 1, so we don't need to access any list. And then I defined the fig size, which is a really useful command to make the figure appear in the correct size from the beginning. And this is actually, this is some normalized units that are usually used by graphics developers. There is some unit, normalized screen unit, blah, that they use. I just have learned that 15, 15, and 7, 7 are good numbers for my screens. there is some documentation on how that actually converts into pixels for different screens. You can look that up.
If you save a plot, it keeps that special size, or does it save it as a standard?
It keeps the size that you specify here, which is really nice. And then instead of writing hist here, we will just write hist 2D and x and y. And then we'll double the number of bins, because otherwise the plot will look super ugly when it's two-dimensional. Actually, we should square the number of bins, but we don't do that, we just double it. And then we'll show both of them at the same time. And I think that will be the last thing we do. Just histograms are pretty staple for any data analysis study, so I thought I should show it.
But you also said that in this matplot lib gallery you can find, yes?
Yes.
And just modify this.
Yes. There are many codes there. So
I needed to install something called Python feast-tk. Someone else has this version. The package. Not in Git, but in Debian.
It's weird that wasn't installed by default.
But everything is weird. I checked now the log. Kolla loggen då på. Det var just den där Git all som ledde den tog bort ungefär hälften av mina paket. Det missade jag, för jag hade glömt dem.
Men vad var det?
Gnomen, man.
Varför det?
Det är helt omöjligt. Jag fick inte åka. Jag tittade på de paketen. De verkar ju fan. Jag vet inte, jag måste ha något beroende.
Because I was really confused.
Jag menar, jag gjorde det på
det var nog liknande, men det var ju den. Jag ser inte det var då det.
Men det måste ju vara för att det är en webb. Alltså
det måste vara någon effekt av testing.
Jo, det måste vara någon effekt av det.
Någon versionskonflikt eller någonting. Jag var uppmärksam på det när jag hade fått mycket mindre problem.
De antagligen håller fortfarande på att fixa problem mellan paket.
Jo, det brukar ju vara så, men det brukar inte vara så där allvarligt. Alltså. Men jag fattar inte att jag inte såg det. Men det var för att jag gjorde jätteinstånd. När man kör aktivt ut, då ser man ju det hela som rätt om det är riktigt illa.
Jo. Men det där var nog en bra läxa.
Ja, det var väldigt bra. Jag tittar på vad man visste vad som står på det.
Ja. Inte bara det, men att så fort man inte har en jättetestad och stabil version ska man inte anta att bara...
Nej, det brukar jag aldrig göra. Men alltså, det var två fel här. Det ena var att jag givetvis inte söker häst och Git och i aktivt. Den är också textbaserad. Och det andra var att jag kollade inte riktigt att den tog, jag måste ha missat att den tog bort det. För den tog bort alltså ett 100-tal paket. Så jag ser ingen vända mig tillbaka i min jobb som sketch, för det är för mindre jobb tyvärr.
Men alltså nu är jag intresserad av vad händer om du installerar testing och sen installerar Git Core för att återskapa. Undrar om det funkar eller om det också bryter av.
Ja, då kan man ju se i alla fall om det blir... Den testen kan jag göra utan att installera det.
Det kan du göra på en virtuell maskin.
Det var alltså Finders var att det var betydligt på både. Det stod klockslaget där hände också, så det säger allt.
So, did you get any cool plots?
Yeah.
And did you get a lesson on why you should do two-dimensional variable analysis? And not just plot one-dimensional histograms.
at the same time. Just look at the two-dimensional histogram and you'll see that they're correlated. Okay, I think we'll end there. So, thank you for today.
Thank you very much.
And I think we will probably schedule some gathering in the coming weeks where I will be here, and those who want to discuss the practical tasks and the homeworks or some other thing that you've tried with Python since then, we can just sit down and have a talk about it and look through it. But I still have to find somewhere in my schedule where I'm free.
So you will have also 2 lectures in the PhD course, one on Friday and one next week on Tuesday. I don't know if it would be maybe suitable for those interested here to attend those or not. I mean, we should not disturb that course. That's the first.
On Friday, I will talk about the same thing that I talked about now last. So the libraries and the matplotlib and IRFwire. So maybe this Friday is not that useful, but the time after that, I will talk about debugging, and that I think might be useful.
That's something after the Code Refinery workshop.
No, that's also on Tuesday.
That's on Tuesday, the day before Code Refinery.
And just send the time.
Code Refinery starts Wednesday morning.
So I can...
Or just say it, or write somewhere.
Yes, I will actually wait. So here. This is
that will be
there.
Då kan vi gärna prata med Peter. Ja. Vi bestämmer det med dem imorgon. Behöver jag vara med? Jag tror om det är någonting så är vi med. Jag tror att det behövs.
What is the code?
Decode?
Yeah, what is the code?
I don't know, for what data type?
Jag skulle åka relativt snabbt. Den här datorn är relativt ny, den kan börja.
Precis för att få en effekt som jag var nöjd. Ja.
They were here. Yeah. So I think we can use the character. So you get able to see what
Because
it's the characters.
But it's a JSON file. What file is a JSON file?
Det är väl bara att avsluta den här, Daniel.
Det är bara att avsluta.
Och